Today I will be solving the LeetCode problem move zeros. This problem covers our basic data structure of two pointers. First, let's see what the problem says. Given an integer array nums, move all zeros to the end of it while maintaining the relative order of the non-zero elements. So we have been provided with an input array nums. In this case, it is 0, 1, 0, 3, 12. And what we have to essentially do is we have to move all the zeros to the very end of the array, while all the non-zero numbers will be at the very left side of the array, as you can see in this output. So the problem here says that we have to move the zeros to the very right of the array. When I was approaching this problem, I did the same mistake of thinking of it in the same way, but we can take a different mental approach when we are solving this problem. So essentially what we can do here is instead of saying, let's say like we are given an array 0 1 0 2 3, instead of saying, hey, let's move all the zeros to the right side, can we not say let's move all the non-zeros to the left side? Because essentially that means the same thing. If we were to say let's move all the non-zeros to the left side, we would do 1 2 3 and then zeros and zeros. So this is a better way to think of this problem mentally. When you approach this problem, think of like, instead of moving all the zeros to the right, let's move all the zeros, let's move all the non-zeros to the left, because essentially that would produce the same output, and it is easier to solve as well. So what we can do here is we can create a left pointer which would be initialized to 0, as in 0 as in the index 0, so it would point to this value here. And what we can do here, and then we can run a for loop. We said for our right pointer, for r in range length nums. So what this for loop does, as compared to let me for r in nums. So what this for loop does, this for loop essentially iterates the r on the index level instead of the value level. So it would not run, it would run 0 1 2 3 4, and this one here would run as in 1 3 12 0 0. So as we are approaching this problem from the point of view of two pointers, so we know that we have to take count of the indexes, not the values. So we say for our in range length nums iterating through our indexes, we say if there I- if there is a non-zero. So this is like a, think of it as like a boolean. Essentially what we're saying, if there is a number at index r which is a non-zero, then we execute this if statement. So this is like essentially our boolean saying like, hey, if there is a number, because 0 is obviously false, as we all know, and then whatever there is a non-zero, it is a true. So we're saying like, hey, if there is a number at index r which is a non-zero, I want to do, sorry, what I want to do is I want to swap the variables. So I want to say, hey, like in this case, the first encounter value is a 0, we do nothing. The second encounter value is a non-zero. What we can do now, we have to essentially swap. So we swap the 0 with 1. So we do something like 1 comma 0. This is what we want to do. So how we do this is we just do a swapping algorithm. This is very easy. We create a temporary variable, and we pass in the value of our L, which is a 0. So temp catches 0 because we didn't do anything when we encountered a 0, and then number at uh, L catches nums R, and then nums R is equals to temp L plus equal 1. So this is what we're doing. Let's run this and I'll explain this code one more time. Sorry, should be nums. So yeah, as you can see, it works. So let me explain what's happening again. We ran a for loop for our input array, and then we said, hey, if there is a number, we want to swap the number with the non-number essentially. And if there is not a number, in this case, the first value we encountered is 0, we just leave it be. R goes to 1, we say, hey, if there is a number, we want to swap R with L. And this is how we do it. We create a temporal variable. We say that the temporary variable catches 1, and then numbers at L. So 0 is equals to catches 1, and the number at R is equals to 0, and then we just essentially just we say L plus equal 1 to make sure that we are returning the output.